let's turn our attention to motion problems. These have had a bad rap over the years. A main equation governing this will be distance is equal to rate times time. But let me help break down the stress here. There are some different patterns involved with these problems. Sometimes we have two trains or cars or planes in different cities and they are traveling toward each other, and the question is, when will they meet? Sometimes you have two cars starting together traveling in opposite directions, and the question usually asks, how long will it be until they're something like 1,500 miles apart? In each of these two cases, there is a total distance involved in the problem. Either in the first case we have the total distance between the two cities, or in the second case they start together, go in opposite directions until they're this total distance apart. Now, if distance is equal to rate times time, and you're dealing with a total distance, you'll have rate times time for one car or plane or train, plus rate times time for the other, adds up to this total distance d. Now technically we need an r1, t1, r2, t2 because the rates and the times might be different, but most people just like to just go with the rt plus rt equals d. Now let's look at another pattern. Sometimes you have two people in cars at the same place, but someone gets a head start because maybe they're a slower driver, and then an hour later another car starts driving, and the question is, how long will it be until the second car either catches up, or sometimes we have one car overtake the other. Those are a couple of words we use. And in this pattern, instead of having a total distance, when someone catches up, they have traveled the same distance. And so with the same distance, you're going to have distance for one car, which is RT, equals distance for another car, which is RT also. Now there's another pattern. Sometimes you are traveling somewhere. Let's say you're going upstream somewhere. You get to your destination, you spend the night, and then you take the stream back to where you started. Or you climb up a hill, then back down the hill. Or you go to Grandma's house and then you come home. This is the return trip pattern. But when you have a return trip, isn't the distance going equal to the distance coming back? So you have the same distance all over again. So I've illustrated for you several different models, all of which that can be written into or turned into two main equation types. And that's going to help you solve a whole bunch of these word problems. And later on then in this course we'll deal with some other distance rate time problems where instead of looking at total distance and same distance, we'll look at total time and same time. And overall, at the end of this whole course, if you look at your problems as either total distance, same distance, total time, or same time, you will have covered almost all the distance rate time problems that are out there. Okay, let's start right in. Okay, a car travels 20 miles an hour slower in a bad rainstorm than in sunny weather. The car travels the same distance, ding 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 ding, in 2 hours in sunny weather as it does in 3 hours in rainy weather. Once you see that same distance, you're going to want to say RT distance equals RT. The one on the left I'm going to label as the sunny weather, and the one on the right, just for organizational purpose, will be the rainy weather. Here we go. A car travels 20 miles an hour slower in rain. So in the sun they're traveling R, in the rain they're traveling R minus 20. The car travels the same distance in 2 hours in sunny weather, so 2 hours in the sun, as it does in 3 hours in the rain. Done. There's our setup. Now all we need to do is do some distribution perhaps on the right and clean this all up. The left side is 2R. The right side will become 3R minus 60. I'm going to get all the variables to one side by subtracting 3R on each side. That will give us negative r equals negative 60, and therefore r is going to equal 60. The units are miles per hour. And I'm going to look back at how I've arranged things. The r was the sunny weather. The r minus 20 was the rainy weather. So this is 60 miles an hour in the sun. And then the r minus 20 will be 40 miles per hour. And that will be in the rain. And there we're done. Look at how easy that was.